Right now, we're talking about a concept that's coming up more and more on the digital SAT. It's a geometry concept, and it has to do with the relationships between the ratios for similar shapes. And we're talking about the ratios of the lengths to the areas to the volumes. Here's an explanation. If you have two similar shapes, and if the side lengths are in a ratio of A to B, then the areas will be in a ratio of A squared to B squared. If by some chance we're talking about a 3D shape, then the volumes will be in a ratio of A cubed to B cubed. And this is all over the recent SAT. So this question is an example of what we're talking about, where we have trapezoid X, and the lengths are 5 times the corresponding lengths on trapezoid Y. So if we just write X to Y, they're in a ratio of 5 to 1. And those are the side lengths. And so, according to the rule I explained a moment ago, the areas would be in a ratio of 25 to 1, because we're just squaring both numbers. Now, on these questions, it's just important to keep track of which is which. So if X is the one that has the 5 and Y is the one that has the 1, now we know the areas are in a ratio of 25 to 1, with the X being 25 times the Y. And that's answer choice C here. So here we have another example. We have one square that has side lengths that are 3 times the other square. So the side lengths are in a ratio of 3 to 1, and we want to keep track with the names. This is the PQRS that has the 3, and the WXYZ that has the 1. Now, if the sides are 3 to 1, the areas are the squares of both of those numbers, so 9 to 1. Now, if we write that as a fractional proportion here, let's go ahead and say we've got PQRS on the top, WXYZ on the bottom, and the ratio of the areas is 9 to 1. Now, the question is telling us that the area of WXYZ is 16. So here we'll have a 16. And so we're looking for the area of the other one, that's X. So as you can see, this concept is heavy on the power of labeling. So just knowing what you're talking about at every stage is incredibly important. So now that we have a proportion, we can cross multiply, and that'll give us 9 times 16 equals 1 times X. So we're just cross multiplying this times this equal to this times this. And on a calculator, 9 times 16 is equal to 144. So X equals 144. And the answer here is C. Now going on to another question. Here we have the volumes of rectangular prisms. So we have the part of the ratio that we haven't really looked at yet. We have A to B for the sides. We have A squared to B squared for the areas. And we have A cubed to B cubed for the volumes, if by chance it's a 3D situation, and here it is. So for P and for Q, the volumes are in a ratio of 64 to 8. And so A and B are going to be up at this first level. And what's the relationship between this level in green and this level in purple? And the answer to that is there's a cube or a cube root relationship. So we need to take the cube roots of both of these numbers. And what is the cube root of 8? And the answer to that is it's 2. And what's the cube root of 64? It's 4. Because 4 times 4 times 4 is 64. 2 times 2 times 2 is 8. Now, what's the question asking us for? It's asking us for the length of the longest side of the rectangular prism. So let's start looking at the information we've been given. So we have prism P and prism Q, and we know that the sides are in a ratio of 4 to 2. So if the longest side of prism P is 8, then we'll go ahead and put an 8 right here. And we're looking for the longest side of Q. We'll call that X. Now we're in a place where we can just cross multiply. 4 times x equals 2 times 8. And let's go ahead and write that out. 4x equals 16. And now we can just divide both sides by 4. And we'll have x equals 4, which is answer choice C. So now in this next question, we're looking at the ratios between the sides and the areas. So once again, sides in a ratio of a to b, areas in a ratio of a squared to b squared. So here we have the length of each side of WXYZ is 4 times the length of the sides of PQRS. So let's write that. WXYZ PQRS. And so this has a 4, whereas this has a 1. And those are side lengths. So those are like saying our A to B. So now our A squared to B squared, that's going to be 16 and 1, just squaring both numbers. So if we write that as a fractional proportion now, we've got 16 over 1 is going to be equal to what over what? Now, once again, that's 16, that's WXYZ, and the 1, that's PQRS. So now, if the area of PQRS is 40, we'll put the 40 here, and we're looking for the area of the other one. We'll put X right here. So now we can just cross multiply to solve. So 1 times X equals 16 times 40. And on a calculator, 16 times 40 comes out to 640. And so our answer here is B. Now going to this last question, here we have volumes, which, as I said before, is a little more rare here. So just imagine that same comparison between the sides, the areas, and the volumes. A to B, A squared to B squared, and A cubed to B cubed. So if we have the ratio of the volumes, that'll be our A cubed to B cubed. So let's just make a little space here. We've got the volumes at 192 to 375. So what we need to be thinking right now is, how can we get that to the A to B stage? Now the relationship here is a cube root relationship because we're going from A to the third all the way up to A. So how do these two numbers relate to cube roots? And what you want to do right now is think about, well, what cube roots do we really know? 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. And we're looking for, how are any of these numbers involved in what we're talking about? And last but not least, 5 times 5 times 5, 125. Well, 192 is really 64 times 3. And 375 is really 125 times 3. So if we're taking the cube root of 192, well, let's say we have the cube root of 192. That's the same as saying the cube root of 64 times 3. 64 has a cube root. It's 4. 4 times 4 times 4 is 64. So this would simplify to 4 cube root of 3. 125, let's do that here. Cube root of 375, cube root of 125 times 3. 125 has a cube root, and that's 5. So you can take the cube root of it, take it out of the cube root, and that's 5 cube root of 3. So we just took the two cube roots, and we can go ahead and put that on our chart. At this top level, we've got 4 cube root of 3 to 5 cube root of 3. And what's the question asking us? The height of one of them is 8. Now, by the way, the 192 pertained to the P, so this is all P here, and the 375 was the Q. So if we're dealing with the heights, those are side lengths, and that's this ratio right here, the ratio of P to Q. That's 4 cube root of 3 to 5 cube root of 3. And we know the height of P is 8, so a side length for P is 8. And what is the corresponding side length for Q? Let's call that X. So now we've got a proportion, and typically with a proportion we'll cross multiply. But this is even easier than that because we've got something that cancels. Cube root of 3 cancels here, and it cancels here. So this is a ratio of 4 to 5. In other words, 4 over 5 equals 8 over X. And now with this easier setup, we can cross multiply. We can say 4 times X equals 5 times 8. So let's do that. 4x equals 5 times 8, 40. Divide by 4 on both sides. X equals 10. And the answer here is D. We hope this video helped you get that much closer to your goals on the digital SAT. We hope to continue producing videos as close as possible to every day, and hopefully you'll hang along with us and maximize your SAT and college dreams. Thanks so much.